Alright, so this is part 2 of my talk about how I built satoshis.place. And in this talk I'll go over some of the specifics for the UX and architecture, and I'll talk a little bit about things that worked and other things that didn't quite work. So let's go through the main objectives for the user experience. So I wanted it to be fast, to showcase the fact that Lightning payments are nearly instant. I needed the drawing to happen almost immediately after the payment was sent. I wanted the game to be cross-platform, so I knew most people nowadays are on the move, so I wanted them to be able to just pop out their phone and be able to use it, as well as trying to support some of the most common browsers, Chrome, Safari, Firefox. I wanted it to be extremely cheap in order to demonstrate the ability to perform microtransactions and provide the cheapest possible way for somebody to experience Lightning. And I wanted it to be simple, delightful, and intuitive for anybody to use. So the game would only try to do one thing and try and do it well. And then I wanted the API to be open for developers to build things on top of it. So in order to represent the canvas, a naive way would be to represent each point as a color hexadecimal value. But a smarter way to do that is to say that since we're limiting the application to 16 colors, we can actually represent that as 4 bits. And we can have a full representation of the canvas with 4 million bits, which is roughly 500 kilobytes. But we can go a bit further by encoding the image as a PNG and utilizing the lossless compression. So the result is a smaller image depending on what's drawn on the canvas, and right now I'm getting about 250 kilobytes for the current state of the board. And actually one of the bottlenecks for the overall speed of the application at the moment is the latency between reading and writing to the database, which I'm using to store the image, which is also not ideal, but that service is on a third party, and I'll talk about ways that I could improve that a bit later. So here are some of the considerations for cross-platform functionality. Responsive design means implementing the UI so that it can scale and readjust on different screen sizes. Touch and mouse support, depending on whether you're in mobile or desktop. There are different JavaScript events that you want to listen for. And multi-touch gestures for pinching and zooming on mobile. The Pixie.js framework actually has a viewport plugin which contains a bunch of neat functionality already built into it, like enabling pinch and other things like decelerating the motion of the scaling so that it's more fluid rather than sort of like a stepped motion. And to make satoshis.place as cheap as possible, a fixed price of 1 satoshi per pixel. Pixels can be drawn over and over again without a limit, and no attempt to incorporate some kind of non-fungible token or concept of owning pixels. Yeah. So in terms of making the application as simple as intuitive as possible, I added a welcome modal at the beginning, so that when a user first visits a website, he would be presented with some information about the game. And since Lightning is new, just a small description about Lightning and maybe a link where they can find out more about it, a link for the API documentation, and I also created a Telegram group where I was hoping to foster some kind of community. I'll talk a little bit more about that later. And also in the background, the application would store a cookie on the browser session. Actually, I was using local storage for that, but it basically, I used that so that on return visits, you just skip the modal and go directly into the application. Avoid cluttering the UI, just trying to make effective use of space and take advantage of things like icons to simplify buttons and tooltips to guide users. And then one way to look at it is to figure out like how many clicks does it take for the user to complete the experience. So at satoshis.place, you need a minimum of 3 clicks to be presented with the invoice QR code. And this is, so you need to select the color, you need to draw something, and then you click to submit, and then you got the QR code. And depending on your Lightning wallet, you might have another 3 or 4 clicks until you make the payment. So the advice here is try to look for shortcuts to minimize that journey. So for example, one technique I used was if the user clicks the pen button, I actually chose a random color for him so that he can immediately start painting, and then he can figure out that, oh, you can also change color. And to make the experience reactive, once the payment arrives, the modal is automatically closed, and the user sees the change take effect on the board immediately. And if you're just browsing the canvas and somebody else draws, you also see that in real time. Reduce barriers of entry. So since it's hard enough for users to use Bitcoin and Lightning, try not to force them to install plugins or browser extensions or even create an account unless you really need to. Nowadays, a lot of the Web3 applications require you to install an extension, and you can only use the application if you have the extension. I think it's a bit annoying for users, and you want to minimize the amount of barriers of entry. And limiting the application to 16 colors is not only good for reducing the image size, as mentioned before, but it also reduces the mental effort required to figure out which color you're going to make your amazing artwork with. There's a lot of other things that you can do to make it more delightful, like adding sound effects or animations to enhance the aesthetics, but there's only so much time. So I think one of the breakthroughs with Lightning will be the ability to chain services and APIs, allowing services to monetize in a metered fashion without having to worry about accounts and permission. So for example, I didn't intentionally implement the image upload function because although it was the most obvious use case to implement, I felt that it would be more interesting to try and get people to do it as a third-party service. And the insight here is that from satoshis.place's perspective, all I cared about was that somebody pays for an invoice. In fact, it wouldn't be immediately obvious whether a payment was done by a human or a machine. But the interesting thing here is that the third-party service could technically be able to monetize himself by creating his own invoice with a surcharge, which would trigger sort of a cascade of payments down to me. And we can extend this idea further and think like, what if there was a website which took votes for the best Bitcoin memes and then used the uploader bot to upload an image onto Satoshi's.place. So this is sort of like layers all the way down, I guess. And with Satoshi's.place, I wanted to explore some of these ideas, and that's why I published the API. And I haven't actually seen a service monetize itself, but there were scripts and bots built for some of the functionality that in that layer 2 there. So yeah, in order to encourage hacking on the API, I made a GitHub page with the documentation, and I held back from optimizing the order payload format to keep it human readable. Yeah. All right, so let's jump into the outline of the architecture for Satoshi's.place. So obviously at the start we have a Lightning node, and this obviously gives us access to the Lightning Network. Then there's a backend server which acts as the brain of the application. It processes new orders, requests new invoices, reads and writes to the database, as well as exposing a WebSocket API. Then there's the database where we store those orders, application settings, and in my case, a base 64 encoded representation of the canvas. And finally, yeah.
Just wondering what you're using for the database.
MongoDB. Sorry, the question was, what am I using for the database? And finally, we have a web server, which the sole duty is to serve the client-side application. So now let's see how everything ties together by looking at the user journey when submitting and paying for a painting. So a user visits a website, the canvas is loaded with the latest image, he draws something and hits the submit button. A request is made to the API with a new order, and the backend service will validate the order, create a Lightning invoice, save that pending order in the database, And the order will contain the payment request, the invoice payment request, and a session ID for the WebSocket connection, as well as a base 64 encoding of the pixels to be drawn, a pixel count, and a settled flag, which indicates whether the order has been paid for. Next, the user receives that payment request, and we show that modal to the user with the payment QR code, the invoice QR code, and the node information. Then two things might happen depending on whether the user has a route or Lightning nodes. So if there's a route and capacity, then the payment will be sent. Otherwise, the user has to go off and open a channel and then wait for that and then come back. Once the payment is detected, the backend will process that by fetching the order from with the payment request, writing the image from the order to the latest canvas image, and then finally sending a notification to the client so that he sees the result, as well as anybody else who's browsing it at the time. And so here's the architecture outline again, this time with the user. You can see how like the web server is decoupled from the rest of the application, and how once the user is loaded with the client-side application, there's a socket connection that connects to the backend. And you can also see how the backend's connected to the Lightning nodes via a socket as well. Yeah.
Is the architecture intended to show that they're running on different machines, or is it just...
Yeah, so the question is the architecture intended to show whether it's running on different machines? And yeah, it is. This is so that if there's demand increases, you can sort of scale those services up independently, mainly the web server and the backend server. Okay, so here are some of the libraries that I use and frameworks. So for the client side, I use next.js, which is a server-side rendering React framework, Pixie.js for handling the canvas, style components for making everything look nice and keeping it organized, and Mobex for handling client-side state. On the backend server, Node.js and Express. The database is MongoDB, and the Lightning node is Bitcoin Core with C Lightning and Lightning Charge. So in terms of like deploying the application, I use a service called Now by a company called Zeit, and the database is hosted at a third-party service called MLab, and the Lightning node is the Odroid device that I have at home for mainnet, and then testnet is Scaleway. So I just wanted to point out that there isn't anything particularly magical about using Lightning in terms of the application's perspective. Essentially, you can think of it as a payment processor with rapid microtransaction capabilities and maybe good privacy. But whether you implement it yourself or use a third-party service, there already are today a lot of options to build your own Lightning nodes with or without BTC Pay, or use a service like Strike or OpenNode. So obviously, the more nodes we have on a network, the better, and I encourage you to run your own node. But if you just need to quickly get started and focus on your idea, then I think there's nothing wrong to using some of these other services. But just remember, not your keys, not your Bitcoin. So I wanted to go over some of the optimizations I had to do. So first, encoding the pixels to PNG was not something that actually was immediately obvious at the beginning. The gains were reduced storage and bandwidth requirements. The second thing was pruning old orders from the database. So I use a invoice expiry of 1 hour, and this means I could reliably delete orders after 24 hours. And the reason for this was because I was on the free tier for the database service, which only gives me 500 megabytes. So this way I could kind of like keep using that. And then setting a request limit on the API was a good idea because there's always that risk that somebody could DDoS any of your like endpoints. And the way I did this was just by tracking the IP and the number of requests made, and enforced a limit of 10 requests per minute. And then I also set a payload size, a max payload size for the order request, and made a check to make sure they're not trying to paint everything at once, which is still possible because you can batch requests. But yeah. So let's talk about some of the things that worked. Word of mouth was very effective for sharing the application across social media. The single board computer running Bitcoin and Lightning nodes worked surprisingly well. I think we can expect that it's going to become increasingly easier for individuals to run their own nodes. I want to give a shout out to Claire's wallet, which was really helpful to use whilst testing satoshis.place. Including testnet as part of your application is, I think, pretty good for users right now. It's also useful for the prototyping phase. You can use reg test as well, of course. Yeah, and some other stuff was making daily backups of your database. So since I'm pruning those orders, I still want to keep track of those, so I just run like daily backups. WebSockets work really well for if you want to create a reactive experience. I use Docker for pretty much all of my projects, so you can build like a consistent local environment and get to think about your application as a set of microservices which you can deploy to production in a scalable way. And then satoshis.place actually ran into some trouble in the beginning because of the amount of traffic on the Lightning node. So the IRC channel for the C Lightning and the Slack channel for LND were actually really helpful. Rusty, Christian, and Roastbeef were super kind and helped me find and fix issues which I was having. And in general, the Lightning community is really friendly. So I just say, like, if you ever get stuck on anything, like don't be afraid to reach out. And by the time I published the API documentation on GitHub, a few people had already figured out how the API worked. But publishing documentation, I think, encouraged people to build scripts and bots and other ideas on top of it. Okay, things that didn't work. The first one was a Telegram group. So when I launched the game, I created a Telegram group where I hoped people would come and talk about the game and have constructive conversations. It quickly devolved into just a lot of trash talking and Bcash spamming and shilling of altcoins. And so I guess, like most people that were seriously interested about talking about Lightning or app development, just moved on. The problem, I think, was that my approach was just laissez-faire, sort of not moderating the group. And this was my general approach with the canvas as well. Because, of course, as the author, I have the almighty power to paint and draw whatever I want. But really, the only time I abused this power was at the beginning when I uploaded an image of my avatar. And I actually did that as a teaser to hint at people that you could actually upload images. But yeah, I think the lesson here is I should have kept some order in that chat group. So another technical issue is the fact that I'm saving the image to the database. This isn't ideal because not only of the read and write latency to the database service, but also each time a user makes a request to just see the canvas, I need to fetch this data from the database, put it into the backend, and then serve it out into the user. And this consumes unnecessary bandwidth, and bandwidth is expensive. So during peak usage in June, the app consumed more than 500 gigabytes in bandwidth, driving up hosting costs by an additional $60. And so, like, a solution to this would have been just to simply publish the image, publish the latest state as an image to something like Amazon S3, and simply link users to that image. And the estimated total bandwidth cost in that case would have been around $5. So I would have probably saved like $55 a month. And yeah, but the other main advantage is it would actually increase the performance of the application. And I really should get to doing that, but nowadays the app doesn't really attract enough traffic to make it worth my time. So the architecture I mentioned previously is missing two important components, which is the message broker and the payment watcher. So these are important when we start thinking about scaling the number of instances of the backend. The message broker is a layer between your client and your backend, so that no matter which backend is processing a transaction, it can find the client that it needs to notify. And Redis is a popular choice for this, and it's also known as PubSub. The payment watcher is a layer between your Lightning node and the backend, and it should be responsible for listening to the payments and making sure that these get processed only once. And this is usually done by making the payment watcher trigger a post request to the backend, so that no matter who the load balancer decides to forward the message, it will only get processed once. So maybe another way to explain this is, in my current architecture, if the backend got scaled to multiple instances, it would actually create multiple connections to the Lightning node and be listening on that. And you probably don't want to do that. All right, so I'm going to end this with a couple of takeaways. Number one, iterate on your ideas. If something doesn't seem like it's going to work, try to identify why and look for alternatives. Keep it usable. Always think about the end user. Focus on making the experience as easy and intuitive as possible. And ask yourself, does this feature make it easier or harder for the user to use my application? Number three is keep it simple. You're going to have a lot of new ideas coming into your mind. Just try and keep a backlog and prioritize. Number four is deploy early. Aim to get your application into the production state as soon as you can, so that you can start playing around with it and share it with people so they can test it. I found it really useful to have it up on staging, so that at any moment I could be like waiting for a bus, for example, and just pull it out on my phone and start playing with the application, and then realize like new things that I needed to fix and improve. Number five is collaborate. Don't be afraid to collaborate with other people. Show your work early and listen to their input. Number six is be careful. Lightning is still in beta. Try not to keep large amounts of Bitcoin on your node. And if your application becomes successful, you might want to consider taking some funds out into cold storage. And finally, have fun. Thank you very much.
You probably had a lot of money coming in initially. How did you manage taking money off of your hot wallet and putting it in cold storage?
Yeah, the question is a lot of money in the nodes, and how did I take it off into cold storage? It wasn't that much money, first of all, and most of it I lost it in a boating accident. But yeah, you can just, there's a command line command to send funds, and you can just like send anything that's not stuck in a channel into cold storage. You can also selectively close channels that you see that have a bit too much money in there.
Do you have a staging version running on testnet permanently, like a duplicate stack?
Yeah, so the question is if I have a staging version, and yes, I do. Yeah.
From the architecture, if people were buying the pixel at the same time, who got the pixel? Like, was it locked in this moment, or was it just the payment that received first got the pixel and the payment that was second just overdrawn directly, or?
Yeah, so the question is if two people drew at the same time, like which pixel got painted first? Literally, whichever payment got received first, or perceptively it would be the last one, right? So if your payment came in before somebody else's, and it was like within a second, then you might just see like the other thing that the other person painted.
So you want to pay as late as possible.
Sorry?
So users
I guess. Yeah.
Two questions. First one is that you back up the image. How often do you need to back up the image and save it? The second question is, did you gather any statistics regarding the payments failures?
The?
Payments failures, payments which will not, which will fail due to
Yeah.
failed routing.
Yeah. So the first question was
How often do you
how-
frequently take
yeah.
the picture?
how frequent do I do the backups? And the second question is the payment failures.
Right.
So the backups, it was just the database backups, by the way, for the orders. They're like daily backups, and because that invoice expiry is set to 1 hour, then yeah, basically like I know that after that period, then it's safe to discard that order.
But you said the image you said, no?
Sorry.
You said the actual image, the actual canvas.
No. So I save all the orders, and there's only one instance of the canvas. So essentially, like if I want to reconstruct the history, I have to replay all of those orders. But I don't have like images for every single.
How long was that replay here?
How long?
Yeah.
In what sense?
Like if you start with like canvas and have to replay it, how long does it take?
Well, however quickly I can process that, I guess. Like, I mean,
Like have you had to do that?
yeah. So I did it recently actually. I went through the orders, and I was basically rendering every single order into an image just to see if like anybody drew any particularly interesting things. But and yet there was a couple, because I wanted to kind of like create a gallery showing sort of the some of the more interesting things. But at least the ones that I found interesting were actually the result of like collaboration. Like somebody would draw, I don't know, Carlos Matos, and then other people would like deface that. And then the result of that isn't like a single order, it's like a combination of them. So grabbing that information is not straightforward.
You showed us a video yesterday where you basically like did a time lapse of the orders. That video is not public, right?
Yeah, so the question is if the video for the time lapse is public, and yeah, it is. Actually, that video is just the YouTube video that I took. That one was made by that friend of mine who helped me with the upload script, because I gave him the order information. But there isn't one that replays like all of the history up until today. I guess we can make that. Yeah.
You were talking about there sort of being several stages of APIs built on top of each other. Is there sort of a standard that exists for how those APIs should look? Something that's sort of multi-stage, make requests, get an invoice, pay the invoice, get the response.
So you're asking about like the different services like chaining off of each other?
Yeah, I mean, like, is there a standard they're following for that kind of format? For
Yeah.
finding APIs?
Yeah. So the question is, if is there a standard for different services wanting to consume from each other? And I don't know. I don't think so. Maybe Chris is the right person to ask about from Shared Bits, right? Yeah.
Not really.
Yeah.
I mean,
Maybe-
you know, like network is a protocol itself, so they connect it.
Yeah.
But in terms of like purchasing different sorts of data, like sometimes we embed the request that you send to us in the description of Lightning for invoice. So that is a way maybe to correlate like what WebSocket request is correlated with what Lightning network invoice payment.
Yeah. There's the HTTP payment code as well, right?
We haven't done HTTP stuff.
Yeah.
Possibly.
I noticed that flying around a little bit, the actual experience of payment is a little bit different than what you described, and so maybe you can explain some of the changes. So it's like invoices expire in 10 minutes rather than an hour. And also the payment request, like, is a copy button. It doesn't copy plain text, it copies something. I'm not sure if, like,
Right. So
instead of a QR code.
So the question is about the expiry of the invoice. I think you're right. It's actually 10 minutes on the user end, but on the backend code, I use 1 hour as the sort of like safe buffer.
Gotcha.
And the other question was the copy button for the payment request. So it's supposed to, if you go on there now, it's actually down the node. Yeah, I'm not home, I can't debug it, but yeah, so it should be the QR code, which you can just scan, or the copy button should be the payment request. Essentially the same thing that you get from the QR code. Yeah.
Did you run into any other like async issues just with all these servers interacting together? You have this like collective canvas that is like your shared global resource here. Like say, for instance, I maybe want to paint over a pixel that I don't like, but then someone else comes and paints over it before me with something I like, so I don't want to place my order again. Like things
Yeah,
like that. And maybe that's just too far down the weeds, but
Yeah, I not really. You mean like the race condition between people wanting to
just
paint?
general things like that. I mean, I'd imagine.
Yeah, I couldn't really think of a solution that was simple enough to implement, and that also plays into the kind of pixel ownership thing, which was like, well, if people are gonna like own them in a sense, or if the price is gonna increase, then I need to keep a map of like those pixels, and then it gets worse in that case, because it's like, say 2 people see the price of a pixel is 10 satoshis, and the next person who paints is going to increase the price by another 10, right? Well, how do you guarantee that the person, you're right? So somebody might pay it for, both of them might pay it for 10, but then only one of them ends up with it, and then yeah, it just was like, well, I don't want to go there.
It spins out of control really fast.
Yeah, I didn't want to go there. And then it just defeated the point of the whole purpose of doing this. But there are people who are building stuff like this. There's I was going to mention it, but I decided to skip. I guess I'll just say it. So EOS right now, there's a thing called Pixel Master, and it's also a similar thing like satoshis.place, but they decided to have this idea of pixel ownership. So if you buy one of their pixels, then whoever buys it after you, a percentage of that will go towards you. A percentage of it will go towards the person who's running the game, and then there's like a pot that has a counter for 24 hours, so that as the pot grows, if the counter runs out, the pot goes to the person who last painted. But if it, so it creates FOMO, right? Because then people are like always trying to reset the counter.
Wasn't there like a Reddit game like that too?
Yeah, it was the April Fool's thing, the button. Yeah, but I don't really like that stuff. I think it's not. Yeah, I don't really like it. All right, I think that's it. Thank you guys.